So we're going to do something called repeated nearest neighbor. Now we know what nearest neighbor is, and nearest neighbor tells us which one to start with. But repeated nearest neighbor, we're going to start with every single vertex and do nearest neighbor. All right, so let's do repeated nearest neighbor on this situation right here. And we're going to start by doing our beginning vertex as A. So if we start with A, and we choose the nearest neighbor, we're going to have 4.4. So we're going to go here. All right, then if we choose the nearest neighbor from E, it looks like 5.8, 4.0, 5.2. It's going to be 4.0. All right, so if we choose the nearest neighbor from C, we've got 6.0, 5.1, 5.6. 5.1 is the closest, but we don't want to close our circuit, so we don't want to go back to A. So 5.6 will be the one that we need to choose here. All right, now we've got 5.8, 4.7, 4.3. 4.3 is the nearest, or the smallest. So let's go there. And now from B, we have 6.0, 5.2, and 5.9. We can't choose 5.2 because that would make 3 edges coming out of E. So we need to choose 5.9. And let's notice that's going to complete the circuit. We have visited everything. So we have A, E, C, D, B, A. Now this is what we got from the nearest neighbor algorithm when we did it the first time. But let's go ahead and get the cost here. So let's see. A to E is 4.4. And then we have 4.0. And then we have 5.6. And from 5.6 we go to 4.3. And then finally 5.9. And add that up. This is 21.2. All right, now that was the nearest neighbor with A as our starting building. Now though, we're going to do repeated nearest neighbor, which means that we are going to choose a different starting point, and we're going to do it for every single vertex that we have. I'm going to erase what I've got. So I've got what the circuit would be like with A as the first vertex. Now I'm going to choose B as my first vertex and do nearest neighbor. So let's see. Coming out of B, the nearest neighbor will be 4.3. Coming out of D, our next nearest will be 4.7. Coming out of A, looks like 4.4 will be the smallest. And then coming out of E will be 4.0 will be our smallest. All right, now we've gone to every vertex. So we really need to close the circuit. So notice if we chose the smallest, 5.1, that would put 3 edges coming out of A, which we can't do. The next one would be 5.6, and that would be 3 edges coming out of D, which we can't do. So we just got to close our circuit now. So what we've got is B went to D, then went to A, went to E, went to C, and back to B. And let's see, B to D was 4.3. And then D to A was 4.7. And then A to E was 4.4. And then E to C was 4.0. And then finally C to B was 6. And let's add that up. That's 23.4. So that's certainly not as short as our first circuit was. All right, so we used B. Now let's use C as our first vertex, and let's do nearest neighbor again. So I'll get rid of all of these. And I'll start with C. Now, coming out of C, 4 is the smallest. All right, now coming from E, the next smallest will be 4.4. Coming out of A, let's see, we have a 4.7, a 5.1, and a 5.9, so we're going to take that 4.7. Then I've got a 4.3, a 5.6, and a 5.8, 4.3. Now we've covered all of the vertices now, so we do have to close the circuit. Let's notice 5.2 would be the next smallest, but that would put 3 coming out of E. 5.9 would be the next, but that would be 3 coming out of A. So we have to go this way. And it looks like we might have gotten the same circuit, but we'll find out. Let's see, C to E to A to D to B and back to C. So let's see, C to E was 4. E to A was 4.4. A to D was 4.7. D to B was 4.3. And then B to C was 6. And this again adds to 23.4. So we know that's not the shortest. All right, so we proceed to do D. All right, so let's start with D and do nearest neighbor. All right, so the nearest neighbor coming out of D will be our 4.3, which goes to B. All right, so from B, my next one, 5.9, 5.2, 6.0, 5.2 is the smallest. All right, now if we go to E, smallest coming out of E will be 4.0. All right, now smallest coming out of C, well, let's see, 5.6, 5.1, and 6.0, 5.1. Let's notice again that we have all 5 vertices. So if we choose the smallest coming out of A, that will take us to E, which already has 2 edges, so we can't choose that one. Next one would be the 5.2, and that will work. I'm sorry, that's not 5.2, that's 4.7, and that will work, and that will actually close our circuit. All right, so let's see what we've got here. We started with D. And from D, we went to B, and we went to E, and we went to C, and we went to A, and we went back to D. All right, so D to B was 4.3. B to E was 5.2. E to C was 4. C to A was 5.1. And then finally A to D was 4.7. And let's see what that is. And this one gives us 23.3, so it's shorter than those other 2, but it's not shorter than the first one we did. All right, lastly, we need to do E. Get all of the old stuff on here. And let's do nearest neighbor with E as our starting vertex. So E, the shortest one coming out of E will be 4.0, so we'll take that one. And then from C, the shortest one will be, looks like 5.1. And then from A, the shortest one is 4.4, but that would close the circuit, and we don't want to close the circuit yet. We haven't visited all the vertices. So 4.7 would be our next one. From D, we have 5.8, 4.3, and 5.6, 4.3. And now we visited all of the vertices, so if we look, the shortest will be 5.2, which will take us to E and will actually close the circuit. All right, so let's see, we went E to C to A to D to B, and back to E. Okay, so E to C. E to C was 4. C to A was 5.1. A to D was 4.7. D to B was 4.3. And then B to E is 5.2. Let's add that up, see what we've got. And this is 23.3. Now, I just realized, I thought it's really weird that these are all very close and that one's not. And I double checked it and I did make a mistake there. So this is 24.2. So if you were questioning that throughout the whole thing, that hopefully will. So that's not our shortest after all. So if we look at this, the shortest two are these last two that we did at 23.3. So we could list either one of these as the pathway that leads to the shortest circuit here. And of course, there's not a whole lot of difference in all of these.